calculator if you don't have one.
Fantastic.
So these sections are really just showing a couple snippets of where logarithms come into play, what logarithms can be used for. The first one is actually used in calculating pH. So you would never, if I put this on the final, you wouldn't have to know the formula, but you will need it to do a couple homework questions, so jot it down real quick. You guys all know what pH is, right, from your science classes?
Yes.
Yes, okay. So it's actually found by doing a negative log of H3O+, which stands for hydronium ion concentration. So we're going to just use this formula, and we will be plugging in either the pH or the H3O+ to calculate the pH. So just manipulating this log. For so part A, I want to find the pH if the H3O+ is 2.5 times 10 to the negative 4. So the formula you just wrote down, pH is a negative log of the H3O+. So this is just strictly a calculator question. We just have to plug that in. pH will normally round to just 1 decimal place. Everybody try plugging it in to make sure you get the correct answer. You should get a pH of 3.6. Got that? Part B, I'm flipping it around. So this time I'm giving you the pH and I'm asking you to find the H3O+. So the pH, so 7.1, equals a negative log . What would I have to do with this? Trying to get to the H3O+. What do I need to do with my negative? Divide it over. So negative 7.1 equals log H3O+. Okay, it's been a week or so, but we can do this. If you have a log on one side, change it to exponential.
Ooh.
All right. What's the base of this log? 10. So it'd be 10 to the negative 7.1 equals the H3O+. So if we type that in, it's not going to give you a very nice answer. You'll notice, like on part A, when I gave you one, it was in scientific notation. Your calculator, you get 7.94, has several decimals, and then at the end it has E-8. That means times 10 to the negative 8. So I'm just going to write it like that. All right. Is that one okay? Yes.
It's 7.1, not 1.6.
Oh,
Any other questions? All right. Let's look at another application then. We also see logs and exponentials when we talk about exponential growth or decay. So again, I'm not going to make you memorize this. I'm just trying to show you some places where these functions come in. So a of t, that's the amount we have at any given time, equals a sub 0, that's your beginning amount, e to the kt. K is a constant. T represents a certain amount of time. If k is greater than 0, then that would be exponential growth. You're increasing the amount over time. If your k is a negative, then that is exponential decay. You have less as time goes on. So we'll try a couple examples with this. I'm sorry, I did print these for you, but the copier broke, and so I was going to be nice, but it didn't work out. It's kind of the story of my life the last couple of weeks, but you know, I was trying. Okay, here's our example. You can abbreviate if you need to. So the key things, if you're jotting this down, we have 80 grams of a substance initially. Sorry, 800 grams. So we start off with 800 grams, and 2.5 years later, we only have 400 grams. How much will be present after 4 years? So we start with 800. In 2.5 years, we only have 400. I want to know how much will be there after 4 years. Let me give you a second to jot down what you want from this question before I start working it out. Sometimes you might hear this called the half-life. Half-life is how long it takes to have half of what you started with. So the half-life here is 2.5 years because I started with 800 and I had half of that in 2.5 years. We need to get an equation from this. So I told you the exponential growth and decay, the amount is a sub 0 e to the kt. Okay, in this equation, we need to figure out what a sub 0 and k are. A sub 0 represents the beginning amount. How much did we start with? 800. Okay, to figure out my k, I am going to use this information. When my time is 2.5, we had 400 grams. So the amount at that point was 400. My time is 2.5, and we're going to find k. So what would we do to get k by itself? We'll have to add a natural log. Before we do that, let's get rid of the 800. What would you do with that? Divide it by 2, or divide by 800, sorry. So we get 1/2 equals e to the 2.5k. So remember, when we're solving these, we can add logs. When we had e, we liked natural log. So we have the natural log of 1/2 equals 2.5k. Divide by 2.5. And we get negative 2.773. So my equation is 800 e to the negative 0.2773 t. That's the actual equation. So then I could find out how much we had at any given point in time. So then my question was, how much would we have after 4 years? So then all we have to do is plug a 4 in for t. And use our calculator. And we get about 263.86 grams. So we had to write our equation, find our K, and then we could find the amount at any given point in time. So is this one exponential growth or decay? Decay, because we have less as time goes on. All right. So far, so good?
Yes.
Absolutely.
All right. Let's do,
Yes, sir. You said 2.
yeah.
You said 152. See, if you know.
It was negative.
I thought you did. Give you credit.
I spit my water out earlier.
No. Hey, I'll be there tomorrow.
Tonight or tomorrow? Can't you? Like, kid. Tomorrow.
Oh, you better do good.
Other questions?
He's from Tuca.
Where's Kid?
Iowa. My boy Diego
He's
lives
from
in Kiev.
somewhere in Iowa.
Diego.
And Chase.
Diego?
And
Wait,
Chase.
did you play basketball with him?
Diego Garcia. He's my son.
Everyone's Snapchat.
Oh.
He has a girlfriend, guys.
Let's look at this one.
Yes, he does indeed.
So how long will it take for the money in an account that is compounded continuously at 5.75% to double? What kind of problem is this?
One where it's that has the P and the R and the N. That one.
Yeah, the one I failed all my tests.
This is an interest problem, isn't it? When it's continuously, remember we had 2 interest formulas, I would put them on your paper or wherever, you wouldn't have to memorize them, but continuously was the one where it had an E. Okay, how is this different than a lot of our other interest problems?
Probably has a long in it or something.
It's probably a good guess.
That's a great guess.
What am I asking you to find this time?
The amount of money once it's.
How long it will take.
How long will it take?
So we're looking for time. So my rate is 0.0575. Did I give you A and P?
Yeah. No.
No, but I said it doubled. So give me a number.
6. 25.
10. 6 was the loudest number I heard. All right, so if we start with 6, if we double it, what would we end with? All right, so you could pick any P value you want, and then your A would be double that. If I said I wanted to triple it, then if my A were 6, or sorry, if my P were 6, my A would have to be 18. So now let's plug in. So we have 12 equals 6 e to 0.0575 t. So now it's kind of like the last problem, where we were solving for our K. What do I need to do first? 6. When we have e's, what do we like to add? A natural log and the e cancel. So then we can divide. Time is always in years, so 12.05 years.
Yes.
Yeah.
Let's
Oh,
go.
now you
I
Questions? Do we need another interest problem? There is one last thing that I want to throw in on this section. This is the change of base formula. So you want to write this down. You can take any log, so log base A of m. I can change it to whatever base I want by doing log of the argument divided by log of the current base. This is most beneficial changing into like log 10 or natural log because those buttons are easily accessible on our calculator. Hello. Okay, thank you. It's handout just on Classroom, but if you catch the end of the video, I'll give directions. Okay, so for example, if I said log base 7 of 12, you could get this on your calculator by doing log of the argument, the big number, so log 12 divided by log 7. I am aware that there is another way to go into your calculator and enter the log base 7 of 12. I know that. I am going to tell you that anytime I give you a problem like this, I will say work required for credit. And you have to write this right here to get any credit for your answer. Okay, so then we can plug that in. So log 12 divided by log 7. And we get 1.27698, so 1.2770. Any questions about that one? Do we need any more examples on that? So that's really the highlights from these two sections that I wanted to cover. If you look on handout, there is on Classroom, there is a handout posted. I want you to do 1 through 8. You don't have to do the last question.